introduction with some critical questions, and then I'd like to open it to the floor. So I think, without further ado, I'll invite Maya to come and give her presentation. So the first presentation is retrospective. It's looking at how the decarbonisation of road freight transport here in the UK has evolved since 2006 or thereabouts, going back 17 years. And then the second presentation from Fernando is going to be prospective. It's going to look to the future decarbonisation of road freight, and that's taking a European perspective. Okay, so I suppose, Maya, this is the sustainable road freight equivalent of COP28. I mean, it's doing its global stock take on decarbonisation. You're doing the same basically for road freight here in the UK. Okay, so over to you.
Thank you, Alan. So because it's our 10th anniversary event, I thought it would be a good opportunity to look back and reflect what we've achieved over the 10 years and slightly more. And how can we use those lessons learned and the past experiences to improve how we address the challenge in the future? So my presentation will focus mainly on reviewing the different decarbonization measures to see how they performed and what went right and what went wrong, and what can we learn from that in the future. The research presented in this presentation is obviously a joint effort, so it's not just me doing it. It's a group of colleagues that I had the pleasure to work with. So I would like to take this opportunity to thank some of them. So first of all, thank you to Alan, who's always been a great mentor. He's been my PhD supervisor, and I had the pleasure of working with him throughout my whole career. So thank you, Alan. I would also like to thank David and Phil and the other members of the SRF team who's grown over the years. So it's been a pleasure to work in a very interdisciplinary environment, and I think it benefited us all. I've learned things I've never thought of. It's the basics of engineering. So that's been great, and of course I would like to thank Julian Allen, who's unfortunately couldn't be here in person today, but it's a great help. It's my colleague from Westminster University, and probably the most knowledgeable person about freight and urban logistics you can ever meet. So it's been a great pleasure to work with everyone, and together we did some very interesting projects, and I thought it's a great opportunity to go back to some of them and see how the outcomes of those projects compare with the reality after all those years. Okay, so let's start with the bad news. Okay, so the graph on the left shows the change in the total greenhouse gas emissions in the UK by mode and the vehicle type. And as you can see, the light and heavy goods vehicles did not really make much improvements over the years. So if we use 1990 as a baseline, the emissions from heavy goods emissions in the UK, the total greenhouse gas emissions from heavy goods emissions were reduced by 1%, and the emissions from light goods vehicles, essentially vans, increased by 62%. Okay, so we do have an issue, and we don't have a data to tell us how much of the van emissions can be attributed to freight. But given the increase in home delivery and online shopping, it's probably quite a significant proportion. What it shows, freight lags behind all other transport modes, essentially freight transport, and we still need to do something about it. And we still need to take action. So that's the bad news. Again, if we look at things at the per kilometer basis, the performance of heavy goods vehicles hasn't been that great either. So there have been some improvement between there's been some improvement between 1990 and early 2000s in emissions, but then it's sort of flattened out. The yellow line, you're looking at the yellow line. It's the yellow line. So it's flattened out, and it's probably because we continue the shift. So the weight, gross vehicle weight in the UK has increased to 44 tons in early 2000s, and the fleets are composed of the bigger vehicles. So the emissions per kilometers are not getting better, but it helped to reduce the overall emissions to some extent. As we'll see in the follow-on slide, there is still a lot of scope to improve our operations to get the emissions down. Right? So internationally, many countries are making great progress to reduce the greenhouse gas emissions. So that's the graph from the latest ITF transport outlook, and it shows the projections of the global freight emissions. And the one on the left is the sort of business as usual, or the current emissions scenario. And it shows we can still expect significant increase in greenhouse gas emissions from freight worldwide. So we know we're near on the target to net zero, and we still need to intensify the efforts to get us to the more optimistic, or what they call high ambition scenario, that will allow us to reduce the freight emissions in line with the Paris Agreement. So that high emission scenario, they reckon, will get us to the plus 1.5 degrees increase as projected in the Paris Agreement. But it also means all stakeholders need to intensify the efforts to decarbonize freight transport. So we as researchers need to develop new approaches to reduce the emissions. So we need research to develop new ways of reducing the emissions. We also need to design a policy environment that supports the uptake of these measures. And we need industry to implement those measures in practice. And to do that, we need to decide which measures have the highest potential and which measures to implement and what the impact is going to be in the future. And over the years, we've been doing this. And today I'm going to take this opportunity to reflect on how good our predictions are, and how good are we at deciding of which measures to focus on, whether you're an academic or whether you're a policymaker or whether you're a company that has to make a decision what technology or what logistics measure to invest in. You need to make that decision, and we should always try to find ways of making those decisions better. And one part of that learning is to look at the past and see what went wrong and what went right. So when we decide on the measures, one very useful tool is so-called what we call a green logistics framework. So that green logistics framework was first developed by Alan, and we extensively used it in research and publications, and it's described in the Green Logistics book if you want to read more about it. But what it does, it essentially translates the volume of freight traffic through a series of different parameters into the total greenhouse gas emissions. So it maps out the greenhouse gas emissions based on those key parameters, and we can then look at the factors that determine the value of those parameters, and use that to decide on the levers we can pull to reduce the emissions. So, for example, one of the important factors driving emissions is the vehicle utilization that can be described mainly by two parameters, the empty running and vehicle loading. And then those factors depend on vehicle carrying capacity and to what extent the vehicle is utilized, and then the level of backhaulage. And then on top of that, we can also map out the different measures that affect one of these factors. So, for example, if we want to improve the level of backhaulage, we can use the load matching services, or we can do more collaboration, or we can use telematics to increase visibility, and so on and so on. So in that sense, the green logistics framework is a very useful tool because it can guide the research on a macro level. So we can use it to map out what's happening in freight transport system at a national scale. It can be used to design policies to support the different decarbonization measures, and it can also be used by individual companies that want to have a better understanding what drives the emissions from the freight activities and have a better feel of which levers to pull to reduce those emissions. So I think that framework is a very has been used extensively in the research because it's very versatile and because it's a good disaggregation of that helps us to disaggregate and get a better understanding of all the drivers of emissions in the freight transport systems. But when we end up, and we have in past publications, we have a list of measures that can be used to shape the value of all these different determinants. But again, the question remains, how do you decide on which measure to implement? How do you decide what's going to be most effective, and how do you predict which one will give you the best result? So let's look at some our past attempts to predict the future. Okay, so in our research and throughout the Center of Sustainable Road Freight and even before, in the Green Logistics Project, we had a number of exercises looking into the future and trying to project what the future will be like. So I'm going to start with a few studies that looking at the trajectories in future emissions. And there's been a lot of different publications that try to predict the future. But I will take the brave approach and look at my own research. So I'm not going to look at other studies. I'm going to look at our own research and see whether we were right or wrong when we when we decided to make some future predictions. So that study precedes the Center for Sustainable Road Freight. It was part of the Green Logistics Project, and it took place around 2007, 2008. And that particular part of the project aimed to create business as usual predictions for the emissions from the UK freight transport. And again, instead of taking a traditional approach to forecasting, the aim was to look at the trajectories in all these different parameters from the Green Logistics Framework and to build up the forecast of emissions based on that. Okay. So let's start with the overall result instead of looking at the individual values. So in that study, and that was based on the inputs from 7 focus groups and the large-scale study, Delphi study, 2-round Delphi survey involving 100 of experts. So it's basically building a collective view of the future. And based on that study, so current situation was based on 2006 data. And based on that study, we expected that by 2020, we're going to reduce the greenhouse gas emissions from freight transport in Great Britain by 10%. Okay, and 2020 is a COVID year, of course, so probably not the most reliable source of comparisons. It's hardly a business as usual year. So let's look at 2019. And if we look at 2019, the data from DFP shows us we achieved exactly 10% reduction in greenhouse gas emissions. And I should finish here. Okay, so it shows us using our collective knowledge and expertise, we can build reasonably reliable projections of the future. Okay, so that's the good news. The not so good news is when we look at individual changes in all these different parameters, out of the four main operating methods for HDVs, our projections were right only for one of these parameters. So the greenhouse gas emissions reduced as expected, but they reduced for different reasons than we initially thought. Okay, so only the lagging factor went in the direction we expected it to go. So you go from 56 to 61%. It didn't quite achieve the same improvement we did, but it's also not pretty much in line. But the share of road transport went up significantly, and it was expected to continue to go down. And running increased, and the average length of haul increased, and was expected to stay stable. Okay, so and that was offset, and the total emissions. So if that was the case, the total emissions should have increased, but that was offset by the decrease in the total ton kilometers for all modes, because what I think happened in the projection, our experts didn't predict the two things. Even though the research was done in 2007, not many people expected to the 2008 and 2009 recession to have so profound and long-lasting effect. So, in fact, the total ton kilometers moved in the UK has decreased instead of increased as expected by our experts. The increase in the average weight of HGVs and hence load carried, again, was the offsetting factor, and the reduction in total kilometers. And we also had some improvements in fuel efficiency, and we also had some switch to alternative fuels. And that was expected in the survey as well. So there was a mix of factors, but the key point is 3 out of the 4 things we didn't get exactly right. So how can we improve on that? So the next thing we did in the Center for Sustainable Road Freight, one of the very first projects we had here, we decided to take a different approach. So instead of trying to guess or forecast, as you may say, the future, we decided to take a road mapping approach. So the essence of the road mapping approach is we agree on the vision and state that we want to achieve, and then we look at the ways to get to the end state. Okay, so we started about 2012-13. We started with a series of micro maps, 10 of them, because we wanted to look at different aspects of sustainable freight. So some were technology related, some were logistics operations related. And we thought we need disaggregated approach to road mapping rather than trying to build one generic roadmap to 2030 that wouldn't give us so much details. And so out of these 10 different themes, let's look at some of the predictions or some of our thinking about the future we apply to those mini-maps. So one way to reduce the emissions from heavy goods vehicles is to use different fuels with lower carbon intensity. So in the 10 micro maps, we decided to focus on gas and dual fuel vehicles. So we created a map and basically that approach, that maps. Again, the full reports are published on the SRF website, so you can go and see exactly what's in that map. That's illustration only. But basically, what it tells between about now and 2030, the gas and dual fuel vehicles should achieve maturity and be widely applied as a transitional technology before we can switch to fully zero emissions solutions. Okay, and what you can also notice from in the initial road mapping exercise, we didn't really look at any electric or hydrogen or other highways or any other solutions for heavy goods vehicles. And it was not because we didn't think they won't have an impact by 2050. It was because we focused on the 10 things first, and the 10 things we thought would have the greatest potential in short and medium term. And then we broadened the range of measures after that. So EVs for heavy goods vehicles and hydrogens were included in the follow-up modeling exercise about 2015. So we looked at that then. The small electric vehicles were included in the urban delivery roadmaps, but we're not going to go into this. So if we take the gas vehicles as an example, we can look at the progress. So to compare if our predictions of them becoming the main transitional technology and being sort of widely taken up by now, to see where we get with that prediction, we can use the simplified Gartner hype cycle. So that is basically a tool that allows us to map out how the technology progresses from the initial idea to the point when it's applied as a market-ready thing by the industry. So when new things get proposed, we all have high hopes for it. It's going to be the next thing, and everyone's talking about it. So we then go to the peak of inflated expectations, and then we actually start some trials, and the trials, sometimes they work, sometimes they don't work. We discover the second order effects and things that don't really go as planned. So we go to this deep of disillusionment, and then the technology matures and improves, and we have some successful implementations. And then we go for the slope and enlightenment, and then when the technology is sort of mature and proven, then it becomes a widespread fix. So for gas vehicles, and that's just my opinion, and it's open to questions and comments. So around 2012, the gas and dual fuel vehicles in the UK were becoming the it thing. Okay, we had advances in fracking and the biomethane, and so there was a big hope the gas and dual fuel vehicles will become the next transitional fuel. And then that expectation peaked about 2015. And then we started some research on the methane slip, on the infrastructure, and so on and so on. And then there are some issues around, and then difficulties, and then the gas prices became a bit more volatile, and so on. So, with the slope, and now the gas vehicles they have placed, we have some successful examples of companies using them. The technology is quite mature. So, for example, we'll probably hear from Justin Laney later today, and just in time. So there are some successful examples of companies using them. So they're on the way to sort of what we call the plateau of productivity. But will they really get there, or will the technology become obsolete before it reaches that plateau? And it may become obsolete for a number of reasons. So first, the volatile gas prices that we didn't think of back in the early stages, and also because of the progress made with other technologies. So So again, it's just my random placement on the graph. So we're making progress with the e-highways. There are some pilot projects that's proving reasonably good results. There is a progress with EVs in the heavy vehicle sector. So when we first built the roadmap for gas vehicles, those other technologies were in the very early stages of development. And if they progress faster than expected, they may replace the bridging solution much faster than we thought. Okay? So I mentioned briefly the EVs for urban distribution, and I think they now close to plateau of productivity. So they've been implemented probably much faster and on a more wider scale than we initially thought. And again, we can think of the reasons for that. And I think the reasons for that is, first of all, the synergies between reducing the greenhouse gas emissions from urban distribution with other health-related impacts. So there are policies in place, the ultra-low emission zones, that promote the uptake of electric vehicles in urban areas. There are also other policies in place. So, for example, in the UK, the government has increased the maximum vehicle weight to allow for the weight of batteries. And also there are some incentives for installing the charging infrastructure. So there are grants available and so on and so on. So that is one of the measures that got implemented much faster and probably to much wider extent than initially projected. Another measure that probably had a bigger uptake than initially projected, and again, in our mini roadmaps, we looked at longer and higher vehicles. And by the way, the credit for this slide goes to Adam, because when we discussed the plans for this session, he gave me the idea of longer, heavier vehicles are actually the ones that went probably better than expected. So I stole a slide from his presentation. And if we look at the international scale, since 2013, we have many different trials and implementations throughout Europe. And most of these trials show very positive results. So if we can consolidate the loads in longer and bigger vehicles, then that shows significant CO2 savings and road traffic service. In the UK, we didn't really follow the lead, but there are two solutions that can be used. So companies can take advantage of no height limit of vehicles. So they can use the double-deck vehicles because the bridges clearances are higher because of the double-deck buses. And also the opportunities for using slightly higher trailers, so 1 or 2 meters higher than a standard. But again, thinking about what went right with the longer, heavier vehicles, it seems to me very much that when one country starts a trial or implements a measure and it demonstrates the significant improvements and benefits, other countries quickly follow the suit. So probably having 1 or 2 initial successful implementations contributed very much to others implementing the measures, and on a sort of European scale, it probably got implemented at a wider scale than we initially thought would be possible. Okay, just to look at some of the logistics measures, we had high hopes thought. One very frequently mentioned is logistics collaboration. Okay, so if we look back at the 2007 study, we asked people what are going to be the different measures that are going to help us to reduce emissions. And one of the measures was collaboration, so logistical collaboration between companies. In the final round of the survey was rated 1.4, where 2 was the maximum increase in implementation. So clearly our experts expected much more logistics collaboration happening right now. It was also logistics collaboration was also included in one of our initial roadmaps. And then again, can have a look at the report. It's much more visible then, but around now we should be seeing way more collaboration initiatives between companies, and also in the 2015 modeling based on the initial roadmaps, we modeled different CO2 savings from logistics measure. And if you see a lot of most of the measures that were expected to bring significant improvements in CO2 emissions have some elements of collaboration to them. So there's a backhaul, of course, to increase backhaul, you can collaborate, there is synchronous consolidation, and there is a use of consolidation center. So there's a lot of the scheduled deliveries. So a lot of these measures have some collaborative elements to them. And we also have a good examples of different pilots and projects looking at collaboration. So if you look at reports from late 1990s, some of them already mentioned the vertical collaboration by one of the UK retailers, Tesco, so that they started probably not for environmental, but more economic reasons. They started so-called supplier collection schemes. So it was either Tesco vehicle collecting goods from supplier premises, or they use suppliers' vehicles for onward delivery to Tesco stores after the supplier drop off the load at the depot. So that's been going on for a long, long time. And then in mid-2000s, we started seeing some examples of horizontal collaboration. So horizontal collaboration is basically two competitors coming together to collaborate to improve the performance of the distribution network. And I think the most famous example, at least in the UK, were two companies, United Biscuits and Nestle, and they started sharing transport resources to improve on the way they distribute the products. And then we had lots of different projects. Okay, so these are just the ones the center and our team was involved with. So we had Starfish 1, 2, and 3. We had City Lab, so some were the urban focus. We had Logistar, we had FTC 2050. So, and I'm pretty sure anyone who's an academic in the audience has been involved in at least one collaborative project in the course of the career. So there was a lot and lots of projects done on collaboration, and some of them focused on proving the benefits of collaboration. Some of them developed tools to facilitate the collaboration. Some of them looked at the sharing the cost and benefits of collaboration. So a lot of projects have been done, but have we seen the increase in collaborative initiatives to the extent we expected to see by now? So did all of that take us to the expected? Do we see many more collaborations in the market? I don't think so. There are some good examples still, there are some projects going on, but it's probably not to the same extent we expected it to be by now. And the question is now, how do we take this and catch up with what we thought would happen with collaboration, and how we then transform that to get us to the physical internet? And the physical internet is a vision of 2050, where all trade will move through this open network. So basically goods or loads will travel, like the information travels on internet right now. So we'll all send our load, and it would use any spare capacity in the transport system and any spare capacity in a depot system. So it's a complete paradigm shift. It's a complete move from privately owned infrastructure to open, almost public type of arrangement. So are we in a position to make that shift? between 2020 and 2050. And what can we learn from the past experiences to accelerate the transition to that? Okay. So a few final thoughts, and I hope, and I'm not giving an answer because I want everyone to think of the answer, and use that presentation to start the discussion and start the exchanges during this workshop. So the final thoughts. So different methods utilizing collective knowledge and expertise can provide some reliable high-level projections of the future. So we can, as a group of experts, come up with a reasonable vision of the future. However, more detailed projections are more difficult. So the question is, do we even need detailed projections, or do we need to decide where we want to get and focus all our attention on finding the best ways to get there? Also, as I said, when we use consensus methods, we're very likely to miss unexpected events. So for example, in the 2007 surveys, we had some open questions on any other comments or anything else you want to mention. And very few people mentioned the likely impact of the 2008 and 2009 recession. And nobody predicted COVID. So these things, if we use consensus methods, the so-called black swans are likely to be missed because we're seeking the agreement between a large group of people. So the question is, how do we use all of this to move us from business as usual to more optimistic scenarios? And again, the key question for this workshop is, what are the key lessons from our decarbonization experiences so far, and how can we use them to do better in the future? So I would like to use that presentation to open that discussion. And a few final things. Some of the things presented in that presentations will be discussed in the two forthcoming reports when we analyze the approach. So first focuses on the sort of government policies to decarbonization, and the other one looks at different trends and review. So they will be available very soon in the next, I hope by the end of the year. And all reports, when they published, go to our